Hi everybody, it's Kiss again. Christmas has just passed. I hope you have a good Christmas, have a good Boxing Day. I don't know what kind of present you got, but back to the business. You got to go back to studying again, especially if you're gonna do IB very soon. Okay, today I picked a standard level question. It's a 2012 time zone 2 paper 1 question. It's still paper 1. And it's again something that I haven't do as a breakdown before. Is something on the binomial theorem. Once you get some crazy power, this is binomial theorem. This is question 7. It's kind of a short question. Well, if you don't know the technique, if you don't know the binomial theorem well enough, this could be challenging for you. Okay, so I want to break this down. Okay, in this binomial theorem, it involves 2 brackets. Okay, so this is one, this is the other one. Okay, you want to expand them out. Okay, and eventually your job is to find n. Okay, given that the first term of the 2 total expansion would be 9 and 84x. Okay, now so there are simple rules to do this. Whenever you see 2 expansions, okay, 2 brackets, you first expand them one by one. Okay, let's do the second one first. 3 plus nx because it looks easier. I think most people can do it. What you do not do is this is, okay, I tell you what, this is definitely not just 9 plus x n squared x squared. If you're thinking of this, go home, revise your algebra, okay? But what happened is, if you want to know why that's wrong, because simply square means bracket times bracket, and obviously in more than 3 times 3 and nx times nx, you will have some 3 times nx and nx times 3, so it would be much more than that. If you want a quick way to do this, it's basically 3 times 3, 9, and then 2 times this times this. So 2 times 3 times nx plus nx whole squared, which is 9 plus, this is 6nx plus n squared x squared. Okay, we quickly expand the second bracket. Now let's go to the first bracket. So 1 plus 2 for 3x. And the problem is, well, it's power n, you can't really expand everything, can't you? Okay, actually you can. Now if you are not familiar with this, you may just as well go to the formula booklet. In the formula booklet, under the section algebra, you will find this, the binomial theorem. They have all this. Now the thing is, I got an XL one here. In SR1 you will see that as well, so you can just use it. Okay, so you can see. Okay, can you see both? Okay, I need to find a way so that you can see both. Okay, binomial theorem. So a plus bn. So this is our a. The second term is our b, so you have a to the power of n, so 1 to the power of n, plus nc1, okay, a to the power of n, okay, n minus 1, okay, to the power of n minus 1. So you just copy the power, and then b is 2 for 3 x power 1. Okay, now the good thing is, since at the final answer, there are only 2 terms, for each of the expansion is actually enough to stop at the second term. So you can actually stop here. To stop, you write plus dot dot dot. Don't miss this. You miss a point if you miss this. Okay. So theoretically, technically, for the power 2, the first bracket, we can actually stop after the second term. But never mind. That's a bit easy. Okay. This is what we do. So 1 to any power is just 1, no matter what that is. And nc1, no matter what n is, if you know, it's actually n. Why? Because you can try. You go press a calculator. 4c1. Okay, 4c1 has to be 4. Okay, 5c1 is always 5, and that's true for any n. So this is n. 1 to any power is 1 again. 2 for 3 x plus dot dot dot. Okay. Next, the 2 terms was multiplied together in the question. So you may want to multiply whatever you got together. So this is basically a crucial step. So we multiply them together. So 1 plus 2 for 3 nx, dot dot dot, that's the first one, times the second term. 9 plus 2nx plus this. Okay, now you are given that the constant term, a term that have no x, is 9. Okay, so in the question we think about how do you get some constant term. It's quite obvious that the only way to get the constant term is to have a number multiply another number which give 9 very naturally. Okay, the next term is the term in x. So the question is, how do you get some term in x? It's pretty easy. You have x times number or number times x. X times number or number times x. So that's what you do. So 2 over 3 and x times 9 plus 1 plus times 6 and x. And that's actually all. You don't have to care about the rest because, well, it's not there anyway. Okay, so plus dot dot dot. You don't have to do anything to the square. So you may want to do some simplification here. 2 over 3 times 9 is 6n squared plus another 6n squared, 6nx, sorry, equals to 9 plus 12nx. And therefore, obviously, 12n would be 84. Therefore, 12n is 84. If you're going to try to get the calculator quickly, you can find this by division, and you should probably get 7. That's your answer. Okay, and that's it. So this is a very quick question that you can do on binomial theorem. If you know the technique, it's actually quite easy. It's quite straightforward, and there's only like 3 kinds of different types of binomial that you can get for SL level. Okay, so for this kind, whenever you have 2 brackets, you need to expand them one by one. You stop at the term that they want. If they want the first 2 terms, you stop at the second term for each of the expansion, and then you multiply them together. Note that what you're trying to do is not to actually expand everything, but just looking for what they want. So when they are looking for constant, you just look at how does some constant be produced. If they're looking for x, you just look at how do you produce some x. For example, x times constant and constant times x. Okay. If, for example, they have one more term which is like an x squared term, at the separate expanding part, you will have the x squared, which means here you will have the x squared. And when you try to expand everything, how do you get some x squared? There are actually more terms for x squared. You have x squared times number times x squared, and also x times x. Okay, so it would be like 3 things if you want to consider x squared as well. But other than that, it's basically the same principle. So I hope you have learned something from this video. This is my breakdown.